Hello, hello. So, having studied science, one thing that always got me was the metric system. And the whole idea the metric system is based on actual stuff, while the imperial system is random. That's one of the arguments people gave in favor of the metric system. Now, don't get me wrong, the metric system does have its uses. It's good for science. But at the same time, the imperial system also has its uses. Um, but I wanted to take a closer look, though, at this whole the metric system is not random, which it is. It actually is. And so the entire metric system is way too long for one video, so I'm going to do this as a series. Not going to do them one right after the other, so next video won't necessarily be on the metric system, but today I'm going to talk about time, because time is a weird one altogether. So the metric basic unit of time is the second, and one metric second is the exact same as one imperial second, pretty much. We took a day. Day is, the time it takes for the sun to rotate on its axis. We called it a day. Split that into 24 hours. Split each hour into 60 minutes. Split each minute into 60 seconds. And it's the same measurement for both metric and imperial. Now, beyond that, we almost never use the metric system for time. We have the second, and that's it. There are no kiloseconds. There are, we don't use it. We do when you go small, we do use microseconds and milliseconds and stuff like that. But we sort of do the same with imperial. Imperial, we could generally measure things down to the second. For day-to-day use, seconds about as small as you need it to go. We started doing things with sports and stuff where, okay, now foot race and these guys are very close to each other and we don't want to report their time as the same, so we started going to tenths of seconds, which what we use for both imperial and, again, metric. Metric's based on base 10. So, the idea that we needed we will call this the flurkin, and it is actually 1/4 of a second. We never measured things to where we had to go to 1/4 of, but with sports, when we started getting things, then it came to, okay, we need less than a second. Well, going to a tenth of a second worked conveniently. And even there are some stopwatches will even go to hundredths of a second, but let's be honest, the time it takes you to click it, your response time, the hundredth of a second is going to not really be reliable. But anyway, my main point there was imperial, we do break it down into tenths and hundredths, which is sort of metric sounding, but is not necessarily metric. And then above the second, we do days, weeks, years, etc., which, again, not metric. But with the metric system, we do the exact same thing. We don't talk about kiloseconds. A kilosecond would be 16.6 minutes, or 0.27 hours, which could be useful. I mean, baking, you bake this for 3 kiloseconds, or until the crust is a flaky brown. Honestly, I think the flaky brown crust system of measurement would be a good one to go by for time. Ladies and gentlemen, this is your pilot speaking. Our current speed is 825 miles per flaky brown crust. That would be an awesome one to go by. But 1 megasecond, that's a million seconds. That's about 11.57 days. Slightly under 2 weeks. Um, we don't do that. We do by days or weeks. A gigasecond, 1 billion seconds, is 31.7 years. So 3 decades. And so for metric, we could go by all those, but we don't because it's really inconvenient. Now, I've worked with radioactive material, and so half-lives. We get down to the very short half-lives, milliseconds, microseconds, nanoseconds actually make sense. But for the larger things, even things where maybe calling this a kilosecond would work, or calling this a megasecond, because phosphorus 32 has a 14.8 day half-life. That's slightly larger than a megasecond. So it would be reasonable to measure half-lives in megaseconds, gigaseconds, kiloseconds, except for the fact that in order to do our calculations, we would have to be using those as a standard anyway. I've got this material here, and its half-life is so many kiloseconds, and I've had it for a week. So now I've got to translate weeks into kiloseconds in order to figure out how much it's actually decayed. So it's easier to stick with the Imperial system. Now, back to my original gripe. We talk about how, we have exact measurements for, or a metric uses exact things we can measure. So 1 second is, back in 1967 when they invented the cesium clock, or the atomic clock as it's better known as perhaps, they came out with 1 second being 9,192,631,770 vibrations of cesium-133. There you go. So, our second, it is based on something definite, and so therefore metric is better than the Imperial. Again, they're the same second, and no, it is not based on that. It is based on the rotation of the Earth, and then when we were able to measure the vibration of atoms, we determined what it would be. But, the second itself is still random. We have an exact thing we can compare it to, but its creation was still a random thing. So everyone who says that the metric system is better because it's not based on randomness like the Imperial system is wrong. It's still based on randomness. Now, while we're doing this, why did we choose the second as the basic unit? Why not use the day? So 1 day, rotation of the Earth, there we have something we can measure our day by. That's going to be our basic metric unit. And then we go to things like 1 kiloday is 2.7 years. 1 year is 0.365 kilodays. I mean, that's not too unusual with other things we measure. 1 centiday is 14.4 minutes. So, again, that's useful. Cooking and stuff, cook for 3 centidays, or until flaky brown crust. So there would be actual useful measurements using, it would be convenient day-to-day things to use the metric system if we made the day the basic unit instead of the second. And we could have gone that route. We just chose not to. We chose to use the second. So our second is a fraction of this randomly chosen, because saying we're going to base our time on the rotation of the Earth is as random as saying we're going to base it on anything else. The vibration of atoms. Supposing we had done it, someone had said, let's base our time unit on the vibration of atoms. Why would they have used a number like 9,192,631,770? Why not just round it up to 10 billion vibrations as a second? Or round it down to 9 billion vibrations as a second? No, we picked this, well, we didn't pick, but we picked a unit and then we found out this weird, complex number fits into it. And we turned around and said, oh, it's not based on anything random. 9,192,000,000, et cetera, sounds sort of random to me. But scientists don't want to admit it. So, so back to the day. Just multiply your 9 billion whatever by 86,400 and we can say, there we go, that's how many days, or how many vibrations are in a metric day. And there we go. It's just as non-random as saying the second is 9 million, et cetera, et cetera. And so that's one of the things I basically wanted to point out. The other thing, like I said, Imperial has its use in day-to-day stuff. You'll find, we have 60 seconds to the minute, 60 minutes to the hour, and this allows us to do things like a third of an hour. A third of an hour is 20 minutes, as opposed to saying a third of a metric hour is 33.33333333 centisec hours or whatever. It's we can do things. That's one of the reasons, Imperial, everyone says, oh, we've got to divide by all these weird numbers and it's so much easier just to divide by 10. Yeah, but for day-to-day use, we want to divide by 3 sometimes. We want to divide by 4 other times. It's, the Imperial system was chosen for day-to-day use. The metric system, again, I make a mistake with my metric system. We're doing, square centimeters, but my chart that I looked up, I used a number for square meters by accident. Now I just shift my decimal point over. I made a math mistake. I used the wrong number, but the number's only off by a factor of 100. Instead of having to, I use square inches instead of square feet, and now I've got to divide my answer by 144 to get the correct answer. I just have to divide by 100 because metric is based on tens. So that is the one thing that the metric system gets easier is, since everything's based on 10, if you do make a unit mistake, use the wrong unit for your calculation, you don't have to do a whole new calculation. You can just shift the decimal point the right direction. Still got to figure out which direction to shift it in, but it's easier to do that than to divide by, especially if multiple units you made a mistake on. I used centimeters by mistake, and I also used liters instead of milliliters and whatever. Now I'm still just figuring out what factor of 10 I shift my decimal point to, whereas with the Imperial, I used inches instead of feet, and I used ounces instead of quarts, and so now I've got to divide by 12 and then divide again by 16, and you're as likely to make a mistake correcting your error as you were to make the error in the first place if you divide the wrong direction. And so that's it. Like I said, time is a weird one because even with the metric system, we still use imperial time measurements. We use the second for both, and then we continue to use the imperial hour and minute and everything else for both science and day-to-day use. As we get into other things, distance and temperature and other things, it'll be easier just to justify some stuff and harder to justify other things. Like I said, no one talks about kiloseconds or centiseconds or anything like that. We do get into milliseconds or microseconds. But again, that's for science purposes, not for day-to-day use. So keeping those separate is easy to do. So that was it. Time was an easy one. Like I said, when we get into other things that we measure, then it's not going to be as easy, and I'm going to have more arguments in either direction, and that's it for now. Like I said, next time I probably won't be talking about imperial versus metric, but time after that I probably will. So have a nice day, and see you in I don't know how many kiloseconds.